We are now going to look at question number 3. The question here reads, a machine has produced nails over a long period of time where the length in millimeters was distributed as normally, 22.0 as mean and 0.19 as variance. It is believed that recently the mean length was changed. Let's stop. To test this belief, a random sample of 8 nails is taken and the mean length is found to be 21.7 millimeters. Carry out a hypothesis test at the 5% significance level to test whether the population mean has changed, assuming that the variance remains the same. Okay, in this question, we are given a normal. We're given a normal distribution where 22.0 is the mean and 0.19 is the variance. So we can say let x be the random variable which represent length, which represent in millimeters. Okay, so then we know that x is normally distributed where mean is 22.0 and variance is this. Now we also know that there are 8 samples that is given that is taken. Now if you're finding the mean, the distribution of the mean, sample mean, what you know is that the mean remains the same, right? Whether you take the mean of the sample and then you want to check the distribution of those sample of the mean, you get it still has a normal distribution, but in the variance part you have to divide it by the sample number. So here n equals to 8. So then we know that if H0, which is a null hypothesis, then we're assuming that the distribution of the mean follows a normal distribution which has a mean of 22.0 and a variance of this number here. Now writing it down properly in terms of the hypothesis of a null hypothesis is that mean does not change, or which means mean has 22.0 value. And also H1 here represent mean is not equals to 22.0, or which means that the mean has changed, or there's an evidence that the mean has changed. Now if you want to test it at a 5% significance level, we know that the 5% significance level will have an area that is 0.95, right? But we also know that we are not given the case where the mean is the change in mean has increased or decreased. So this is like a case where the confidence interval is 95%. So the confidence interval is 95%, significance level is 5%. So it means that the area here will be, so this area will be 0.25, right? So then if this area is 0.25, the area here will be 0.975. So then we can say that probability of mean where you have less than this C here will be 0.975. Okay. Now we will simplify this. We'll find the answer for this one now. Again, if you standardize this, we know that probability here, Z variable, is less than C minus 22 divided by sigma. Again, because we know that sigma square is this value here, 0.19 divided by 8, this implies sigma equals to 0.19 over 8 whole root. So if we take this to be a sigma and then we divide it here, we will get the value of C. So then if you look at this quantity here, the inverse of this area will give you a value of Z to be 1.96 here. So that's why here I've written 9.6 here. Okay. So, or you could say something like Z equals to phi inverse of 0.975. This is 1.96. You can get this value from the standardized table or directly from your calculator. Okay, now if you find the value of C, this becomes C equals to 22.302, right? So that's C equals to 0.2302. But in this case, in this interval here, but this is for the 25%. So there's another 25% here. So if you want to find this value here, so this will be, let's say A. So the value of A is just 22 minus the interval that's from here to here, right? So this interval is just C minus 22. So, and we know that C minus 22 is this much. So if you subtract 22 with this one, you get 21.698 and 22.302 as a interval of acceptance region. Now, as we are dealing with the questions of hypothesis, we have to give a valid conclusion so as to say whether we accept the hypothesis or not. Now we are given that the mean length found for the sample of 8 was 21.7. Now this is in the acceptance region, so we can see that 21.7 lies in the acceptance region, right? So it means we can say that there is not enough evidence to show that the population mean has changed. It means we are accepting the null hypothesis. So if we are accepting the null hypothesis, it means that we are accepting that mean hasn't changed, or we're saying that there is no enough evidence that the mean has changed, right? So then this is how you should be writing the solution. Okay, so now we'll move on to question number 4.